Why do we need data? It's to analyze and to make decisions. Okay, so give me some basic calculations. You know what the difference is between a parameter and a statistic. Okay, so what are some basic stats?
Basic calculations.
Yes, average.
Median, mode,
that would be mean.
quartiles,
Good. Quartiles, mode.
yes.
Good. Okay.
Percentiles.
Percentiles, exactly.
Yes.
Well done. Right, so when looking at those measures, you need fancy notation to do statistics because you're not going to write down 1,000,000 or 100 different values. You're going to write down one symbol, which is this, summation.
You put the E and the A will be 1,000,000, and I is your starting data.
Correct, and those are all the observations. Good. Okay, so if I've given you this data here, income, expenses, assets, liabilities for different companies. Okay, let's give them variables. Okay, so I've given those variables to each and every one of them. W represents income. Okay, so 100,000 will be represented by W1 and 2 and 3. Okay, the different amounts. Okay, so if I'm asking you for this, what's the answer for that symbol? That summation symbol from 1 to 3 for xi. Remember, xi is x observation. So x observation 1 to x observation 3. So what would the summation be for x1, 2, and 3?
It would be 40,000, 300,000,
Which is?
1,340,000.
Exactly. Okay, and see, that's how you use the summation. Okay, you're not really going to see too much of this because your paper is multiple choice. If it was written, you would. Okay, what's the summation for that one?
25.5 million.
Correct. Okay, that's it. Happy with that? Alright, there's the note about population and statistic. Okay, statistic is for a sample, population will have a parameter. Okay, the one is looking at inference, the one is looking at the stats. Okay. We can make deductions based on the population from the sample. Okay, because it's impossible to survey everyone. So you survey a sample and you draw up certain conclusions. Right, so I want the mean for those data, for that data.
Can I do that on stat?
Yes, you can. You use the 1 minus VAR.
It's 1 minus VAR.
Okay, just the sample mean is given by this, x bar, and the population is given by u. Okay, it's called mu. Mu is a Greek alphabet for that. What's the sample mean? Yes, that is correct. 28,71. Correct. Good. Okay, what's the median? The median would be the middle term. Okay, so if I've got 3 terms on that side and I've got 3 terms on that side, 28 is the median. Okay, because you need to rank the data from smallest to biggest. Okay, happy with that? Right. A few other measures that you can get. Mode, which you spoke about. Greatest frequency. Median is the average. Median is the middle. Okay, what happens if I have a weighted mean? What do I then do? You need to take a portion of each of the weights. Okay, yes, okay. So if I'm looking at the mean, okay, there's a few examples on this page. So I've just referenced 1 or 2. If you go to page 126, you'll see a list of values. Okay, but I'm happy you know how to work out the mean. Okay, this is the weighted average interest rate. Okay, so how much am I investing? 5,000. And I'm investing a portion in that portfolio, a portion in that portfolio, and a portion in that portfolio. Okay, so how do I get the weighting? I need a percentage of each and every one of those values. Okay, so it's a percentage of that, a percentage of that, and a percentage of that over the total. Okay, that's how you get the weighted average. Okay, so the weighted average mean, right, for this particular example is 14.08%. Okay, because a portion is invested in a different portfolio. Okay, these are just 2 examples from the textbook. No, not textbook, study guide. There is no textbook for this module. Okay, so it's just the weighting of. It's the weighting of divided by the total. Okay, I haven't seen any past paper test that weighting. Okay, the weighted average. Right, but it is covered in the textbook. Well, your study guide is the textbook. It might or might not cover.
And then I'd obviously multiply that times by 100.
Yes, to get a percentage. Okay. All right, what is variance?
Variance is square root of the standard
No.
deviation.
Standard deviation squared.
Oh, yeah.
Standard deviation is square root of the variance. Okay, that's the relationship between the two.
Point of the variance.
It's a measure of spread. Okay, so standard deviation.
Spread from the mean.
Exactly. Okay, it's central location. It's measures. It's a measure of variation, spread, or dispersion.
Okay, and the standard
Because-
deviation is the average spread of each figure.
It's looking at that. So this would be the average.
Yes.
Okay, this would be the deviation. The variance would be a measure that represents the degree of spread. Okay. All right. So I want the mean, I want the variance, and I want the standard deviation for those 5. Use the calculator. 1 minus VAR. You just need to know which symbols to solve for.
So variance 3,3.
Is the variance 3,03? No. Okay, you should be getting a mean of 7. You should be getting a variance of that, and a standard deviation, which is that.
Just try this again.
Mean is x bar.
X bar, I've got a 7.
Good. Standard deviation. Remember, the calculator doesn't give you variance. The calculator gives you standard deviation.
So n minus 1.
Yes.
That's my standard deviation.
3.39.
3.39.
Good. Now just square it.
Square that. And then I get 11.5.
There we go.
Okay.
Okay. Be careful. See, that's the difference on the
This
calculator.
thing doesn't give me.
The calculator can't give you variance. The calculator gives you standard deviation. You get variance when you square it. Okay, makes sense? Good. Okay, if you wanted to do it manually, that's how you would do it. You don't need to use fancy equations. This is a multiple choice exam. Okay. All right, here's another one for you to try. Quickly work that one out. Okay.
The mean is 20.42.
Correct.
I have standard deviation of 8.5.
Correct.
So then my variance is 72.
Good. Okay, those are the answers. Great. Okay, so you've got the 3 answers. Happy, right? Simple. Okay, the next bit is this, the straight line. Okay, and the reason why we need to recap this is because of linear regression. Okay, linear regression is when I have a series of points, I'm trying to get a line or a relationship that represents all of that data. Okay, so what does the M represent? The slope. And the C? The y-intercept. Okay, so if you had to draw an axis, right, this would be your C and that would be your slope. Exactly. Okay, so to get the slope, it's always a change in y over change in x, and that gives us the slope. Okay, so can I have the same thing for a set of data? Yes, I can. Okay, because data will be scattered on a chart, okay, like a scatter graph. And we're trying to look at something that best meets the relationship between all of those points. Okay, so remember, graphs can be drawn, and if I had to draw a graph, I'll have an x-intercept and I'll have a y-intercept. Okay, the calculator gives you the slope and it gives you the y-intercept. Okay, so if I'm looking at correlation and regression analysis, okay, we first need to identify what R stands for. What does R stand for? It's a correlation coefficient. If something is correlated, there's a link between the two variables.
Between 0 and 1, or -1 and 1.
Minus 1 and 1, that's it.
One is a perfect positive relationship.
No, 1, yes, 1 is perfect positive, correct?
Negative 1, perfect negative.
Yes, and if there is no relationship, it's random. Unrelated, correct. Okay, so if there's a strong positive, if the one moves up, the other moves up. If it's negative, the one moves up, the other moves down. Okay, if you square the r, you get the coefficient of determination. What does that mean? That means the variation of y is explained by the variation of x. It's looking at the scope. You'll see that in an example just now. Okay, so if you square the r, you get the variation of y is explained by the variable x. Okay, so there's the scatter graph. Okay, is there a best estimate here? Yes. Do you agree? If I had to draw a line, it would be looking something like that, right? Okay, so how do I get that line? I need to use the stats mode on my calculator. Okay, A is the intercept, B is the slope. Okay, that you need to know, okay, because I've seen students mix it up. Okay, sometimes students don't use the right letter for the right, let's say, variable.
Okay.
A is the intercept. B is the slope.
I know that the slope is p with x. That's
Yeah, of course, but B is the slope. So when you work out B on the calculator, it's the slope.
okay.
Okay, because the B goes with the
Do
X.
I do that in separate?
Yes, but it's linear regression, so it's the AX and BX. That's the second option.
A plus b.
A plus BX, yes.
There you go.
Okay, so here's the list of values. So plug those values in into that table that you now have on your screen. Pardon? Really?
Yes, he has some experience in most people do some stats like that.
Okay. Yeah. Alright, so that's good. Yeah, this actually does come from the stats notes because I've got those slides as well that it's all stats. This is just part of it. So
Okay, so I've done that now. So do I do the same thing with stat? Meaning what I do?
regression.
Regression 7.
Yes.
Okay, and do I say A, I say B for the slope.
Yes. A.
B for the slope, so it's 2.11.
Yes.
Okay, and then I just go step regression, and I say A is 0.92.
Good. Okay, see, and if you wanted to do this manually, that's how you do it. Okay, that's how you find all these figures here come from your calculator. Yeah, you'd rather not because the calculator does it for you. Okay, but that's how you would get those values. Okay, if you go back to the stats mode and look for the summation button.
Summation button.
The sum button.
Oh, hang on, I'll go, yeah, this one. Sum.
Okay, so now let's read which figure? Let's read this one. X squared.
Okay, so 1.
91.
Okay.
Okay. That's how
So
you
that's
get it.
all programmed in there.
Yeah. The calculator does all of it in one step.
Okay.
Is that alright? Yes?
Yes.
Okay. I want A, B, and R for this one.
A, B, and R. Okay, so let's
Okay.
see if I can use that right there.
Which is the independent variable?
X.
Which is what? Advertising or sales?
Advertising.
Good. Advertising should affect your sales. Good. Okay, so insert and solve. What are we getting?
So A I've got as 9.1.
Good. And what is A?
A is my whites.
Good. See, you know this.
B I've got is 0.5A.
Well done. Okay, there you go. That's it.
Regression. So R is my coefficient of correlation.
Correlation coefficient.
Okay, coefficient of correlation. I square that to get coefficient of determination.
Yes.
Okay.
That's good. Okay, so you got that R, eh?
Yes.
Okay, there you go. Alright, so R represents what? A strong positive relation, meaning we would expect advertising to increase our sales.
Yes.
If the advertising goes up,
Yes.
the sales should go up. Okay, there's correlation.
Yes, okay.
Right, last one. Quickly do that one. We've got a rate and we've got new homes. Okay, in terms of loans, starts. Okay, the rate would be your x independent variable, and then the start would be y. Let's see what sort of graph we've got here. Your stats is good, so I don't think you'll have a problem with this section.
No.
From what I've seen today, you're strong with the working, so that's good. Yeah, well, in 2 weeks, after the public holiday next week, we'll look at the past paper. I am going to ask you if you can email me last semester's paper. I've got previous semester's papers, but I want to do last semester because I don't have a solution for last semester, obviously. Okay, so let's try do last semester's paper and try go through all of them. All right, so you're happy with the workings. What did you get? Correct. Good. Nice one. Okay. You just got to be careful when doing this. That's the yes. All right. So is there a positive or negative correlation here? B is the slope.
Yes.
Yeah. So it's sloping downwards, and the R should come out as negative.
Yes. The R is negative.
Yes. Okay. So maybe just to discuss this, if I square the R, what does that mean? It means 29%. Okay, so remember we spoke about the coefficient of determination. Okay, so if you square the R, you get 29%. So what does that mean? That means
29% chance that X is going to determine Y.
Exactly. See, that's what it means. There you go. You've got an understanding. Okay, good. All right, and that's the note that I've tried to show you here. Okay, in terms of a variation and the coefficient of determination. Okay, you've got the correlation and the determination here. In terms of the explanation, so a variation of y can be explained by x. Exactly what you just said earlier.